In this video, we are very excited to present our work on enhancing voice-driven face generation with audio denoising. First, let's look at our problem. What is a talking head model? A talking head model takes in a speech audio as an input and uses digital technology such as deep learning to create lifelike facial animations as our output. It aims to think faces with audio input. In real world, it's mainly used in movies, games, VR, and assistive technology. There are many existing talking head generation models, such as speech-to-face, think-talk-face, and gene-face. Now let's look at an example of a talking head model output.
And legs enough for the number, but the moorlands had little other right to the word.
There is a challenge of talking head models that it is sensitive to the noise in the input video. Let's see an example.
And legs enough for the number, but the moorlands had little other right to the word.
To address the challenge of noisy input impacts lip syncing and expressions, our objective of the study is to reduce the impact of noise on the quality and reliability of talking head generation models. The method we use in the study is to add an audio processing block in the model to denoise and enhance the audio input. We have two major methods. First, we trained our own implementation of a denoiser module. Second, we fine-tuned a pre-trained audio denoiser and enhancement module. Our study has the potential of broader applications and real-world effectiveness in real-world noisy inputs.
Here's our model implementation, which takes a noisy audio, goes through a denoiser module, and produces a denoise output. And this is passed into a talking head module, which will produce a render frames of a person's talking video. Our denoiser module is a encoder and decoder architecture, which has a multi-layer convolutional approach with unit skip connections. For more details, please see our paper. And our model architecture is inspired by this paper called Real-Time Speech Enhancement in the Waveform Domain. Our face generation model is inspired by GenFace, which takes in a audio and generates the lip motion, and they thus render a face talking video. So after it is denoised, our audio is looking like this.
And legs enough for the number, but the moorlands had little other right to the word, for they were in general very plain. And
we can see that after it is denoised, the person's lip becomes clearer than the noisy version.
And legs enough for the number, but the moorlands had little other right to the word, for they...
Now let's see what our dataset looks like. We have three types of different noisy input. The first type is random noise. The second one is environment noise. And the third one is overlapping speech. We have developed our own training and validation dataset using existing datasets. Our speech data comes from the LibreSpeech ASR corpus. In this training dataset, we use the train clean 100, and in the validation dataset, we use the diff clean dataset. We have three different types of noise. The environment noise comes from the FSD Noisy 18K dataset. The random noise is randomly generated white noise, and the overlap speech comes from the same speech dataset, and it is randomly selected.
Here is a summary of our experiments and results. The main evaluation metric we used is the SyncNet confidence score, which is derived from the difference between the minimum and median of the Euclidean distances calculated between audio and video features. It is a numerical value that a higher score indicates a stronger correlation between the audio and the visual speech. For our final denoising module, we took a pre-trained model and fine-tuned it to our dataset by training it for 50 epochs with reduced learning rate and batch size. We ran the talking head model with the original audio, the noisy audio, audio denoised by pre-trained model, and audio denoised by our fine-tuned model. And here are our average results for different types of noises. As you can see, our denoising model makes the talking head video generate more realistic lip-synced results.
To summarize our study, we constructed our own new train and validation datasets from existing datasets, and also we observed a decent improvement in talking face generation quality with our fine-tuned model with the denoising module, compared with both the baseline module with no denoising module and the model with the pre-trained denoising module. Our results are optimistic for generating talking head videos from inputs in noisy environments. Our next step include first increase the types of noise added, such as randomly erased speech audio, and also we will continue to train and fine-tune our from scratch denoising module implementation. Thank you.